Бачу, що ми всі зібралися, тому пропоную розпочинати. Сьогодні у нас другий день національного фіналу Всеукраїнського юнацького водного призу 2026. Ми заслуховуємо 6 проєктів наших суперфіналістів. Захист відбувається англійською мовою. Презентація буде показана та, яка демонструвалася вчора. Відповіді на питання, відповідно дискусія з журі також буде відбуватися англійською мовою. Тому в порядку черги, яку я вчора вам надіслала, пропоную розпочати. Вовк Антон, Павлюк Маргарита, Волинський науковий ліцей Волинської обласної ради, проєкт «Особливості використання дистанційних даних для оцінки водності території на прикладі Волинської області». Are you ready?
Yes, of course.
Great, you can start.
So, good afternoon, dear audience. We are Margarita Pavlyuk and Wolf Canton, and we would like to present our research title, Features of Using Remote Sensitive Data to Access Water Availability of a Territory, Case Study, Volyn Region. Next slide, please. In the era of climate change, water availability and moisture supply of territory significantly affect both the environment and human life. Rising temperatures disrupt the water balance, which is especially noticeable at a regional level. The Volyn region, once excessively humid, has repeatedly faced prolonged droughts and declined groundwater levels over the past decade. Therefore, we decided to develop a method of monitor water bodies and water resources using remote sensitive data. You can see the aim and method of our research on a slide. Next slide, please. The study area is the Volyn region, which covers 20,143 square kilometers. The evaluate of effectiveness and reliability of index, and to determine the most suitable one, we select several test sites with different surface characteristics and show on the slide. Each selected site has unique surface properties and accordingly different moisture level. This allows us to obtain a wide range of results and assess the applicability of index for various conductions. Next slide, please. At an initial stage, we used satellite imagery platforms such as Copernicus browsers and EO Land Viewer, where we selected images for specific dates and analyze them using indexes such as NDWI, NDMI, and others. We also used Google Earth Engine with data from the SMAP satellite. The workflow in Copernicus browser is as follows. First, we study area limits are created in Google Earth Pro. Then we used uploaded into Copernicus browsers where Sentinel-2 data and the statistic took selected. After choosing the time period, the platform automatically generate graph. The data can be exported in CSV format for perceive analysis. Next slide, please.
So results. Our NDWI analysis showed that water bodies like Lake Sweeties have high but variable values due to wind and waves. Other sites such as forest and cropland show clear seasonal patterns based on vegetation growth and harvest time. Meanwhile, the NDMI index proved to be more sensitive to plant moisture than to overall water availability. Next slide. Standard indices are not perfect for every site. After testing several options, we found that RDI and SR-sphere indices provide the most accurate results for mapping surface moisture. Next slide, please. We also monitored water coverage at Lake Tursk and Kovaly Wetlands. Although the average area around 1,000 hectares, we observed significant fluctuation caused by water inflow from surrounding areas. Next slide, please. Using the GLDC dataset, we analyzed soil moisture at different depths. By combining this with preparation data, we can better visualize more how moisture levels change over time and across the region. Next slide, please. Finally, SMAP satellite data allows us to track daily moisture changes. This helped us compare extreme periods such as dry conditions of 2017 versus the wet condition of 2020, and monitor the moisture decrease in spring 2020.
Next slide, please. To identify cause and effect relationship between water availability and weather conditions, constructed correlation metrics. The analysis show that uplands areas of Volyn are more sensitive to temperature change than lowland. The correlation between NDWI and maximum temperature is minus 0.66 in uplands compared to minus 0.57 in lowlands. The key factor for both landscapes is air humidity. Meanwhile, the moderate correlation with precipitation indicates that water availability in summer and autumn is mainly determined by evaporation intensity and temperature rather than rainfall. Next slide, please. This slide presents the algorithm we developed, which outlines step-by-step action for conducting similar studies. Next slide, please. Our project has strong future potential. The results can be applied globally, which gives it significant international relevance. The developed methods and algorithms allow for quick and a suitable use for remote sensitive data to access water availability in any region. You can see the main conclusion of our work in a slide. Thank you for your attention.
Thank you. So please, questions. I can start from first question to you. What is the main difference from your previous year project? Did you hear me? Anton?
Sorry, can you repeat, please?
Repeat.
Yes.
What is the main difference from your previous year projects?
So we add some new information. So Google Earth Engine, we change some code. We use a new data set in our new work. So if we can repeat the slide number 8 maybe. So we also add climate data and data about rains. So this is a graph on number 1 with 3 lines and with 2 lines and
Okay, I understand.
Thank you.
You are now last year students, as I know.
Yes.
So what are you going to do the next? Are you going to continue with your project or maybe something new?
So we will try to check information from satellites by ground methods. Maybe this is the main our perspective.
Okay.
And also take a long time for our research.
Okay, thank you. More questions, please?
Yes.
May I please? Dear participants, can you please tell me, is the calculation methodology you used is available for nowadays, or it was developed by you?
Okay. So these indices are very popular, and we don't create these indices, but we create the algorithm of using how to use every one of these index and also compare with other satellites data.
Okay, and one more question. Do you think your result will be of interest to the international community?
Yes, we think that yes, because we can use this algorithm for any other territory. This is like the example, and then another scientist can take our algorithm and did it for a territory that they are interested in.
Thank you very much.
Thank you. Тетяна Євгенівна.
Okay. Can you formulate what is the
Тут дуже
absolute
погано
value?
чути, Тетяна Євгенівна, дуже погано чути.
Я не знаю чому. Зараз краще?
Зараз краще, так.
Так. Can you tell what is the absolutely new? Maybe is it absolutely something absolutely new in your proposition, in your work?
So we create the algorithm that includes a lot of methods. We create one algorithm from a lot of research, another research. So maybe it's the main our
Okay, thank you. I have no
okay,
more
thank you.
questions.
Thank you. More questions? Okay. Thank you, your team, for this great presentation, and go to the next project. Так, Желєзняк Ілля, навчально-виховний комплекс школа комп'ютерних технологій, Львівський технологічний ліцей, спосіб оперативного виявлення екологічних проблем. Are you ready?
Yes.
Please start.
Hello, my name is Ілля Желєзняк, and today I am happy to present you my project called A Method of Rapid Detection of Environmental Issues. Next slide, please. So nowadays, our ecology is rapidly changing. A lake may begin to bloom or trees may start to get sick. But the main problem is that people notice these changes too late, when the damages already have been done and restoring ecological state is very expensive. Next slide, please. So in the ecology and biology, scientists are using multispectral cameras, but this method is very expensive, requires high computational power and hard to use. Next slide, please. So suppose a process that proceeds normally and generates light quanta at two frequencies, like on the figure 5. Suddenly process changes and starts generating photons of the same frequencies but at different proportions. And in this moment, our photodetector won't notice a change. But when we add additional light filter, this changes light spectrums in narrow visible light, and this makes possible to photodetector to distinguish between these two variants. Next slide, please. And because of that, I decided to stick to the method of the light filters. I selected green, yellow, blue, and 2 shades of red. Next slide, please. After that, I created a program using Python and several libraries. In the program, there are 4 modes. Firstly, when user opens a program, he can add categories and select an images for them. In the point mode, user can select two images and place points on the first image, and on the second they will appear in the same coordinates. User can change radius and delete the points. And when user places a point, program calculates average color in area of the point. Also, we can export analysis data in PDF or JSON. And in JSON, we will see information about mode, information about image, like image name, image path, and image resolution, and also data about the points like index, coordinates, radius, and average color. Next slide, please. Second mode is the grid mode, where user selects two images and the program divides them by equal fragments. Program calculates average fragment of each fragment, average color of each fragment, and average color of the whole image. Compares these two values, and if difference is greater than selected percent, the program will highlight the fragment as potentially harmful. And the third mode is an artificial intelligence mode, where user can select an image, run the analysis, and AI will find pollution objects like bottles or plastic, and output name of image, name of found objects, confidence, and position of the boxes. And last mode is image filter mode, where user can select an image and make more variants, like with light filters. Next slide, please. To increase accuracy, I decided to create my own artificial intelligence model. I trained it on Yellow 26 medium version by the company Ultralytics, and I had a data set of around 2000 images with water debris, and now AI can classify up to 10 different classes of pollutions. Next slide, please. During the training, AI model dramatically decreased the losses, and precision and recall stayed at around 80%. Next slide, please. Also, I want to grab your attention because a few weeks ago, I got a letter from University of Texas at San Antonio, where Professor Hatim Sherif expresses high support of my project, and we plan to test my program in their university. Next slide, please. So, conclusion. Hypotheses were confirmed. My program helps us to find ecological problems faster and cheaper. And the main advantage is that this program is available to everyone. Thank you for your attention.
Thank you, Ilya. So, questions? Who can start? Please, Vita Vasilyevna.
Ilya, can you please tell me why did you choose the YOLO 12S network for your task?
Yes, of course. Firstly, when I was learning about artificial intelligence, I have used YOLO 8S and 8N, but when I had a bigger data set, like 2000 images, I selected YOLO 26 because it got me better results than another models. Because I have used augmentation and more images in my dataset.
Okay. Tell me, please, how does the quality of the images affect the accuracy of your method?
I have trained on the images with 640 pixels of resolution. This is a base resolution for all classification AI models. But the better the resolution, the better will be a result of finding the debris in the water, but it will increase delay of analyzing image by the AI.
So we observe the difference in results according to the quality of the images, yes?
Yes.
And another one question, does the time of the day when the images were taken affect the accuracy of the method?
Of
Morning,
course.
afternoon, evening?
Okay. Of course, if it affects, but AI were trained on the images of the afternoon time, but the main purpose is that if objects can be seen visually, the AI can find it.
Okay, thank you very much.
Thank you. More questions?
Okay, I can ask. Ilya, tell me please, how long did you work under this proposition, under this project?
At this moment, I communicating with the university at Texas, and we plan to firstly make testing at their university, and then maybe launch it like a program for use of everyone. And the use of program can be used by images from drones, and I plan to expand the AI with more images and more classes.
I right understood that you started this work from the very beginning with this specialist from Texas University.
No. Specialists in Texas connected with me after my work has been done.
And my question was, how long did you work under this project? When did you started?
Okay, I started last year at autumn.
Last year it's 1926?
25.
2025.
1 year, yes?
Yes.
Okay.
Nearly 1 year, yeah.
Mm-hmm. Okay. Thank you. Very interesting work.
Thank you.
More questions?
Hello,
Yeah.
I have a question.
Yes.
Ilya, can you say or explain where do you take photos or images to analyze with your program?
I think that the best source of images would be data from drones, but also we can place cameras at the trees near the rivers or some water banks. And when water flows, we can analyze images with the AI to find debris, calculate the count and number of them to understand our issues in the ecology.
Okay, so this is sounds like this is an idea to take photos from drone, but is it what you did? So you took photo from drones, or you took it from other?
No, I have took it manually by my phone and spectral filters.
Can you then explain, in the very beginning you showed the different spectral filters. Can you explain again why did you put these filters? What is the purpose for the filters?
The main purpose is that with spectral filters we can see more details of the image. Because how I explained it, the additional light filter helps us to see more details in narrow spectral parts of the image.
It's clear. Can you give an example of such a difference? You showed on the next slide, I think you show a tree.
Yeah.
So with the filters, you can see more. Is this what you mean?
Yes, because with each filter, we can see some parts with different colors. Like on the yellow filter, we see more a part of this like white patches, and on the red filter, we see less information.
And if we look at the tree with no filter?
If you look with no filter, it will be more like distributed. We can see like selected these patches.
Okay. Last question. Then when you upload the images to your software, what is the result? How is the result? Is it a file, or it's an image, or it's a list of problems? How it looks like?
For the user, there are 4 modes, and in my opinion, the most reliable is the AI mode. And in AI mode, you can use one image or folder with images. And user can export analysis data with JSON or PDF file. In JSON, we will have name of mode, information about images like resolution, path and name, and data about found classes, confidence of AI model in foundings, and position of objects on the image. And in PDF file, we will have image before analysis, image after analysis with boxes, and information during the analysis, like in JSON mode. And also additional page where we have like histogram with number of classes, distribution of confidence, and also spatial map of detections on the coordinate map.
Sounds complicated. So will we see like this area has problem with pictures, this picture has a problem with waste, plastic bottles? Is it like this, or it's something more sophisticated?
It's like this.
Okay, thank you. Thank you.
Okay, more questions? Okay, I have the last question to you. Do you know similar methodology in Ukraine or abroad?
I have researched it, but the closest method is method in the farming, where farmers use multispectral cameras to investigate the how much they will get wheat, for example, or some crops.
Okay. So thank you, Ilya.
Thank you.
And go to the next project. Мироненко Олексій, Сироїшко Богдан, учні Лісоводського професійного аграрного ліцею з проєктом «Раціональне використання дощової води в громаді села Лісоводи». Are you ready?
Hello, everyone.
Just wait a minute for your presentation. Okay, so you can start.
I am Сирішко Богдан. My name is Олексій Вероніка. We are from the State Education Institution, Лісоводський Professional Agrarian Tourism, which is in the Хмельницький region. And your project is about Лісоводи and water of Лісоводи. Who such a project? Because the land of forest and water is which there are 2 rivers, 5 ponds, and at on time. Reclaiming system was introduced due to the overflow of soil, which were water in toys realities has encountered a problem. This infrastructure is global in the whole world. The lack of drinking water. Next slide, please. Our project, rational use of rainwater in the community of the village of Lysovody, was developed on the basis of 5R. Next slide. Next. Our project included study and analysis of information on water as in our area, development and experimental substitution of the findings of the integrated system of collection and nature purification of rainwater to reduce the consumption of sanitary water in the household. Next slide. In the process of carrying out the work, we create a research model of a water collection and purification system, which consists of four interconnected blocks. One block for collecting atmospheric precipitation, 2 block primary cleaning system, first flash, 3 block strong tank. Next slide. And 4 block biofluidation model. Next slide. We also carried out practical conclusion to determine the possible annual volume of rainwater collection, the area of the buildings, roof, and the average amount of precipitation in the region were taken into account. The roof area from which water is collected is 49 square meters. So from 1 square meters of roof per year, approximately 600 liters of water can be collected, and from one household per year 28,800 liters. And if this system is installed by 100 households, the volume of annual collected rainwater will be as much 2 million liters of water. The actual collection rate is approximately 19%. Next slide, please. This volume would allow to significantly reduce the load on water supply system, to reduce the risk of water shortages, to reduce electricity cost for water transportation and purification, to reduce the overall ecological footprint of the community. Next slide. I am Bogdan.
I am Oksy.
We are from the land of forest and water. We are from Proftech. and we are convinced that having a simple home system for collecting and naturally purified rainwater implement on a mass scale can have a significant ecological and economic effect at the level of a settlement. And if your project were scaled up to the entire country, this would be an incredible effect. And in today's realistic crime is the tears of the sky over wounded Ukraine, which we can learn to turn into a source of life. Postscript. We did not interact water for our ancestors. We brought it from our children. Every saved drop of water is an investment in the peaceful and prosperous future of your Ukraine. Thank you.
Thank you, guys. So, will we have question?
I have one question.
Yes, please.
How does your offer differ from existing analogs? Any existing analogs?
Repeat, please.
Can you hear me?
Repeat, please, question.
How does your offer differ from existing analogs? Any existing analogs? Do you investigate? Did you investigate different research in this area?
Macat. Only macat.
Okay, thank you.
So, any questions? So, thank you, guys, and go to the next project. Федюніна Вероніка, Ліцей Наукова зміна міста Києва, фотокаталітична деградація стійких органічних забруднювачів у воді. Вероніка, are you ready?
Yes.
So you can start.
So, good afternoon, everybody. My name is, as it was stated before, Veronika Fedюніна, and I'm a 10th grade student at Ліцеєм Наукова зміна. The topic of my research is photocatalytic degradation of persistent organic pollutants in water. We go to the next slide. So, every year, increasing amounts of persistent organic pollutants enter wastewater. This includes pharmaceutical compounds such as antibiotics, whose main sources are pharmaceutical industries and improper disposal of medication by human societies. The presence of such compounds in water bodies poses significant risks to ecosystems, increasing antibiotic resistance in bacteria and thereby making their elimination process much more difficult. For example, in developing countries such as Nigeria and India, where relatively high concentrations of the fluoroquinolone antibiotic ciprofloxacin are found compared to other countries, an increased level of antibiotic resistance in bacteria is observed, which is approximately 80%. Traditional wastewater treatment methods such as filtration and chlorination have proven ineffective against persistent compounds and antibiotics pass through conventional treatment facilities with little to no change. Therefore, new and more efficient water purification technologies are needed. One such method is photocatalysis. Could we go to the next slide, please? So photocatalysis is the acceleration of chemical reactions under the influence of light and a catalyst. When light strikes a photocatalyst, it generates reactive species, which are hydroxyl radicals. These radicals, they oxidize complex organic molecules of antibiotics in my research and degrade them into low molecular weight compounds. Next slide, please. Among other water treatment and organic compound degradation methods, photocatalysis stands out due to its environmental safety, as it does not require toxic reagents and does not produce harmful secondary byproducts. Its accessibility, due to its ability to be carried out using natural or artificial light, and its efficiency, as it ensures deep mineralization of organic pollutants into safe compounds. So the next slide, please. In my study, I synthesized 3 different photocatalysts based on zinc and nickel oxide. They were all thermally treated on specific temperatures. For example, for zinc oxide, it would be 400 degrees by Celsius, and for composite, zinc oxide plus nickel oxide would be 240 and 400 degrees by Celsius. One of the objectives of my research was to confirm the effectiveness of the synergistic effect in composite materials. The slide shows the synthesis of the photocatalysts using the co-precipitation method, and on your right you would see the photocatalytic degradation process, which is UV radiation under magnetic steering, and the analysis of the results. So the next slide, please. After UV irradiation, UVB spectra were recorded. Their analysis shows a decrease in peaks at a wavelength of 278 nanometers and an increase at 195 nanometers. This indicates the degradation of benzene rings in the original compound and the oxidation of its components into low molecular weight substances. Next slide, please. So using the exact values of optical density at a wavelength of 278 nanometers, I calculated approximate values of the residual concentration of ciprofloxacin in the samples. On average, this value decreases by 53.5% from the initial concentration. Next slide, please. For a broader understanding of the experiment, I also measured pH, salinity, and electrical conductivity. And during the experiment, the formation of hydroxyl radicals occurred, and it is evidenced by a sharp increase in pH from 5 to approximately 9 to 10. Both salinity and conductivity increased threefold regardless of the photocatalysts used. This indicates the degradation of ciprofloxacin molecules in the initial solution and an increase in ionic products due to photocatalytic activity. It's confirming oxidation processes. So next slide, please. Therefore, in my research, I reached the following conclusions. Photocatalytic degradation of persistent organic compounds in water using semiconductor photocatalysis is a promising method of water purification characterized by both high efficiency and environmental safety. The study showed that composites based on zinc and nickel oxides exhibit enhanced photocatalytic activity due to the synergistic effect between their components. And this is confirmed by UV spectroscopy results, where at a wavelength of 278 nanometers, as was stated before, the absorbance intensity decreases on average by 53.5%. And in the case of the zinc oxide plus nickel oxide, composite, which was thermally treated at the temperature of 240 degrees, it decreases by 72.7%. And also an increase in photocatalyst exposure time also leads to a higher degree of ciprofloxacin degradation due to the destruction of benzene rings. So the last slide, please. For my project, I see different proposals to enhance it. For example, by using samples of real pesticides or real samples of wastewater, and also attempt to prove my last statement of my conclusions by increasing the exposure time to the photocatalyst to have some practical proof of the fact that it leads to a higher degree of degradation of a compound. That's it. Thank you for your attention. I'm looking forward to answer your questions.
Thank you, Veronica. Questions, please?
Okay, I will start with questions, okay?
Yes.
Veronica, tell me please, at which form you're now studying? Is it last form or not?
What do you mean?
Or at what class, okay?
I'm a 10th grader.
Huh? Repeat, please.
10th grader.
You will study one more year, yes?
Yes.
I asked because you did really very good investigation. It's very interesting. But as for me, the more interesting list is the propositions. And really, you started very well. But it would be very good if you will prolong this work and obtain the answers to the questions which you noted in these propositions. For example, sunlight, more time of lighting, and so on. Okay. Another second question is: did you tested the original side of your work? Is your work really original and the results, or maybe somebody else investigated the same?
Could you please clarify, because I didn't get what is original?
Sorry?
I didn't, could you please clarify, because I didn't quite catch your question.
Okay. Is your work is original?
Yes.
Yes, you are the first who studied these materials as photocatalysts.
Not really, but I have some originality in my project. For example, I have studied different works of different scientists, and throughout my study, I have noticed that none of them have tested these composites, which I used, which is zinc oxide plus nickel oxide at different temperatures, thermally treated by different temperatures. And in my study, I have noted that, for example, if we thermally treat this composite by lower temperature, which is 240 degrees by Celsius, it will show greater photocatalytic activity and greater results. By this, I mean a greater degradation level of the original molecule of the antibiotic.
Thank you. I have no more questions.
I
Okay,
have a question. Veronica, can you give an example how you would apply your results in Kyiv? For example, in Kyiv municipal water supply or in Kyiv wastewater treatment plant. Is it possible?
Well, actually, it is, but in my study, I have actually used like real small samples of this water that contained ciprofloxacin. So even though I mentioned that it's low cost due to the fact that you don't have to spend too much money on producing these oxides, these composites that I have used for this experiment. Actually, to perform this real, like to apply it in real environment, you need to have some money, because actually the problem with this experiment is the fact that to use photocatalysis, you actually have to use quartz glass, because it actually allows UV to pass through it, because the usual glass UV can't pass through it. And the main essence of photocatalysis is the fact that it needs, like, it's efficient to have it's essential to have UV light exposure, and only with usage of quartz glass for this experiment, by, like, for example, we have some kind of tube, a big one, for example, it has to be produced out of quartz glass, and you could put lamps, like UV lamps around it, and that's how it would be performed. And I feel like it might not cost too low.
Yeah, but for any application, we will need money. So this is,
Yes, I know, but
this
like, yes, I
But
know.
at this stage, you can just dream about implementation of what you do. But if you understood correctly, so the water should be transparent. So to apply the
Yes.
catalyst, the water should be transparent. Is it right?
Yeah, that's right. But like, if I could mention, before using that, like before applying photocatalysis to that water, you should actually filter it to the state where there would be like a greater UV light. Oh my God. Wait. So it would be and like easier for UV light to pass through it for
go
the
through the water.
Yeah, yes, to go through the water, and also like for only the stable compounds to be left in it to perform the photocatalysis on them. And usually, as it could be performed, you will use very what is the antonym for sick? I'm sorry. I'm trying to think of it. Wait. A very shallow layer of water. This is what I mean. And
To
that's
let
how
to let the light go through it.
Yes, that's what I mean.
Okay, then again, I will come back to my first question. So what do you think then? Will you use, if you have enough money and
If you
enough
have
money
yes.
for the quartz sleeves, would you use it for wastewater treatment or for the tap water treatment?
I would. Oh.
Which water is more transparent? This
Well,
would be one of the answers.
Tap water, but
I have also the question on this contaminant that you studied, have you tested the water, any water source in Ukraine? Does this contaminant is present in our water? Do you have this data?
well, actually, yes, but like not as big amounts as, for example, in the countries I mentioned, such as India and Nigeria, I think, yes. So in those countries, it's, for example, around 300 nanograms per liter, which is a huge amount of the antibiotics in the water. And I think for Ukraine, it will be a much lower number, but it's still present. For example, around 30 nanograms, I think, per liter. It's still present, and this is still a problem that we have to fight with. But the solutions that I have tested, the photocatalysis on, they were made with me, by me.
Okay. The last question, why did you study these two countries, India and Nigeria?
I didn't study these two countries. This is just the example. This is just the example that I have found in my study. There are different countries. For example, in Poland, I think the amount of ciprofloxacin molecule in water is also huge. It's not as huge as for Nigeria or India, but I just studied the data of worldwide to see this problem.
Okay, I think it would be your work will be much more valued if you will show the concentration of this particular contaminant all across the Europe at least, or if you show it all across the world, then it would be even more curious to know.
Oh, I had a graph at the second slide with a lot of different countries. I just mentioned those with the biggest concentration.
These are countries.
Yes.
They're very small. Now I see. Thank you. I don't have more questions.
Thank you, Veronica. More questions? Okay, so we can go to the next project. Так. Хамдош Іскандер, Науковий ліцей Державного університету Житомирська політехніка, проект «Комплексна діагностика стабільності та гідродинамічне моделювання еволюції водно-болотних екосистем басейну річки Гнилоп'ять». Are you ready, Іскандер?
Yeah.
Okay.
Okay, I will start soon. Good afternoon, dear members of the jury and participants. My name is Iskandar Hamdosh, and I'd like to present an overview of the results of my research on the topic: comprehensive stability diagnostics and hydrodynamic modeling of the evolution of wetland ecosystems in the Gnilopiat River Basin. Next slide, please. Under conditions of global climate change, wetland ecosystems are undergoing intensive transformation that critically affects their hydrological regime and their capacity to sequester organic carbon. According to global research data, from 30 to 90% of wetlands in various regions of the world have already degraded, which underscores the need for comprehensive monitoring of their evolution. The Gnilopiat River Basin, as a typical example of wetland landscape of Zhytomyr Policy, requires detailed stability diagnostics to develop scientifically grounded strategies for water resource management and adaptation of water management systems to climate change. Next slide, please. Therefore, the aim of the research is to carry out a comprehensive stability diagnostics and to develop a forecast of the evolution of wetland ecosystems in the Gnilopiat River Basin through integration of geochemical analysis of bottom sediments, the information entropy approach, remote sensing, and hydrodynamic modeling. The research objectives are shown on the slide. Next slide, please. To achieve these objectives, a set of methods shown on the slide was applied, combining field reconnaissance, hydrochemical and biogeochemical analysis, information entropy methods, GIS, and remote sensing, as well as statistical data processing. Next slide, please. Now, regarding to the results. Hydrochemical analysis of the bottom sediments revealed a critically high content of organic matter, 15.9%, which exceeds the peat formation threshold, and an anomalously high concentration of manganese, 135.34 milligram per kilogram, serving as a direct redox indicator of reducing conditions. A nitrile pH of 7.3 and a low electrical conductivity of 0.38 millisiemens per centimeter indicate intensive leaching of the sediments by infiltration waters. Next slide, please. The information entropy assessment confirms the critical state of the system. The normalized entropy across 28 parameters reached 65.8%, exceeding the 60% threshold. The most destabilized were the subsystem of general sediment indicators, 87.5%, and the subsystem of meso and micro elements, which indicates laws of self-organization and the formation of conditions for irreversible changes. Next slide, please. Satellite monitoring using the CDOM index for the period from 1995 to 2024 confirms the progressive accumulation of dissolved organic matters. Values increased from 0.91 in 1995 to 30, with values exceeding 1.5 in 2024, with the expansion of the zones intensifying particularly after 2011. The next slide, please. The dynamics of the MDWI index over 1995 to 2024 demonstrate a progressive transformation of the basin's water regime, whereas in 1995 the spatial distribution was dominated by moderately negative values between 0 and minus 0.2. By 2024, territories with values below 0.3 and 0.4 had expanded significantly, reflecting the spatial differentiation of overwetting and the extensions of waterlogged zones. Next slide, please. Modeling of heavy metal migration based on the Beer-Bachmann equation confirms the high sorption capacity of the bottom sediments. The retardation factor for copper is 26.7, for zinc 52.4, while manganese retains high mobility, which confirms its role as a sensitive indicator of reducing conditions. Forecasting by the Streeter-Phelps model for the 2025-2035 horizon revealed the persistence of conditions favoring further waterlogging, with summer minimum of dissolved oxygen as at 6.9, 7.7 milligram per liter, and elevated BOD values. Next slide, please. Allow me not to read the conclusions aloud, as the main findings were already presented in the course of the report. The research materials were approved at the International Scientific and Practical Conference. One article was published in Scopus Indexed Journal, and 2 articles in specialized Ukrainian journals of category B. The results was implemented in the activities of Ecological Innovation Ltd. And the NGO Sustainable Development Fund of Ukraine. Thank you for your attention.
Thank you, Iskander. So, questions? Okay, I will start from one question. What do you think, how you can implement the results of your project, or maybe the methodology on international level?
Thank you for a question. Our research is directly can be implemented. Firstly, our systems can be our methodology is directly transferable of wetland ecosystems worldwide because it relies on universal accessible tools and data. For example, the satellite component uses free Landsat and Sentinel-2 imagery available through Google Earth Engine or NASA for any location on Earth. Our Hydrus 1D models software is freely available and widely used internationally. The geochemical diagnostics criteria we established, for example, organic matter threshold above 20%, manganese as redox indicators, and nitrogen ratio as an aerobic marker are based on universal biogeochemical principles, not region-specific conditions. Also, the Polisa region shares hydrological characteristics with extensive wetland zones in, for example, Poland, in Baltic states, Finland, Canada, and a lot of other countries. Tropical peatlands in Southeast Asia, which are experiencing critical degradation, could also benefit from our entropy-based stability assessment approach. So the key adaptation required would be local calibration of model parameters and slight index threshold. Also, I see a particular potential for collaborating with Scandinavian researchers studying boreal peatland hydrology, and with institutions involved in the EU Horizon Europe water resilience programs, because our approach aligns directly with the objectives of the Ramsar Convention and supports reporting under United States Sustainable Development Goals number 6, number 13, and number 15. Yeah, thank you.
Okay, and one more question. As I understood, it's quite well-known technology, methodology in the world, yes? So what is about your project? You propose some kind of new approaches. What is new in your...
What is the value?
Yes.
The main value lies in creating an integrated diagnostics and forecasting methodologies that didn't previously exist for these types of ecosystems, like individually geochemical analysis, entropy assessment, satellite monitoring, and hydrodynamic modeling. Each provide only a partial picture, but our integration of all 5 methodological layers within a single basin revealed something like no individual method could show. A self-reinforcing water lodging cycle. Specifically, we demonstrated that the dominance of leads to water of infiltration over surface runoff leads to water stagnation, which creates anaerobic conditions, which was confirmed by manganese accumulation, which in turn promotes organic matter preservation at 15.9%, which further reduces oxygen availability. Also, the entropy-based stability assessment with critical value of 65.8% provide a quantity early warning metric, and the 10-year forecast projected CDM expansion of the territory gives policymakers concrete data for water resource management decisions. So the main value is creating a new approach to assess the condition of different ecosystems, which is really good approach because it combines a lot of different methods and can be used worldwide. Yeah, thank you.
Okay, thank you. So more questions to Iskander?
Can I ask?
Yes.
Could you clarify me your fourth conclusion? What fundamental patterns of wetland landscape transformation have you identified?
Thank you for your question. Which main foundation of what? Could you repeat?
What fundamental patterns of wetland landscape transformation have you identified? The first sentences in your fourth conclusion.
Thank you for your question. From climate change, we get data from the platform Land and Water, which showed us the climate conditions from 1991 to 2020 period of time, and this data confirmed the waterlogging processes on the Gnilop'ять River Basin. Also, with that data, we developed a water balance scheme, which showed us an absolute dominance of infiltration on stock. So we can say that climate change directly leads to changes in hydrological regime in wetlands. Also, we can say that anthropogenic factors also leads to changes in wetlands because of anthropogenic pressure, for example, of different from building a lot of different buildings, a lot of different like factories. It all like have a direct impact towards wetlands because of pollution of air, or pollution of water, pollution of like wetlands. So the main anthropogenic factor that affects our wetlands is pollution, mechanical pollution, or like air pollution, all directly like affect the changes in wetlands. Thank you.
Thank you.
Thank you. So, more questions? I guess no. Thank you, Іскандер. Так, колеги, і це був на сьогодні останній проект. На жаль, Цимбалюк Ксенія не зможе доєднатися і захистити свою роботу. Вона зламала ногу, як написала її керівниця, тому можемо побажати Ксенії тільки найшвидшого одужання і продовжити свою роботу. Я пропоную за годину зустрітися всім. З журі ми зараз залишаємось на обговорення. Всі учасники і керівники о 18:15 за цим самим посиланням ви можете зайти, і ми будемо оголошувати результати нашого суперфіналу. Члени журі, скажіть, будь ласка, чи потрібна нам перерва на 5-10 хвилин? Чи можемо перейти до обговорення?
Давайте обговорювати.
Добре, тоді чекаємо, поки всі учасники і керівники вийдуть, і почнемо. Так.
Ну, а що ж ми маємо зробити? Що ми можемо зробити?
Так.
А вони були?
Керівники, да, деякі були, але у нас всі наші сьогодні суперфіналісти вже є. Вирішили зробити трошки раніше оголошення, бо з одного боку опрацювали результати, а з іншого боку, щоб не затримувати час. Отже, колеги, друзі, так, учасники, наші суперфіналісти, я надаю слово голові журі Тетяні Євгенівні Мітченко, яка скаже декілька слів про ваші роботи і загалом про те, як все це відбувалося у нас.
Все, я можу говорити?
Так.
Так, ну я вас вітаю, наші дорогі учасники, і хочу, я сповіщу вас про результати, нарешті, не тільки про хід. Ну, що я хочу сказати, що цього року, ну, ви знаєте, що ми проводимо цей конкурс вже 21 раз, 21 рік, і різні були учасники, різні були рівні учасників, але цього року був напрочуд високий рівень практично всіх учасників. Ми навіть, ну, зокрема, я навіть не чекала такого. Але ви просто неймовірно зростаєте. І сьогодні нам було не завжди досить важко обрати найкраще, тому що ці хороші. Але цього року була взагалі якась така цікава ситуація, що перше місце було обрано єдиногласно, і ніяких питань у журі не було. Такого я не пам'ятаю ніколи. Ну, добре, почнемо. Сергій, ви можете? Так? Окей. І так, третє місце одержали Антон Вовк та Маргарита Павлюк за роботу особливості використання дистанційних даних для оцінки водності території на прикладі Волинської області. Робота дуже хороша, робота виконана на високому рівні. Взагалі цього року було багато робіт, що стосувалися дистанційних даних та їх обробки. Але ця робота була однією з самих найкращих. І велика пошана керівникам цього проєкту і, звичайно, учасникам. Друге місце одержали два наших фіналіста. Це Вероніка Федюніна і Хамдош Іскандер. Вони одержали дуже близькі оцінки, високі, дуже близькі оцінки, і таким чином обидва зайняли друге місце. Вероніка Федюніна з роботою фотокаталітична деградація стійких органічних забруднювачів у воді. І дуже приємно, що її керівником є Марта Ігорівна Літинська, це старший викладач кафедри технології неорганічних речових, водоочищення та загальних хімічних технологій імені Сікорського, тобто наша колега. Ми її дуже поважаємо, вона дуже така розумна і перспективна особа, і дуже приємно, що вона підготувала таку хорошу учасницю нашого конкурсу. Вероніка, я хочу тобі побажати, щоб ти не зупинялась на цьому, в наступному році у відповідності з тобою ж сформульованими перспективами довела цю роботу до якогось логічного такого завершення і знову прийняла участь у нашому конкурсі. І будемо сподіватися, що це дозволить тобі вже стати суперфіналістом у всіх значеннях цього слова. І Іскандер Хамдош з роботою комплексна діагностика стабільності та гідродинамічне моделювання еволюції водно-болотних екосистем басейну річки Гнилоп'ять. Теж чудова робота, на дуже високому рівні виконана, дуже здорово оформлена. Я, як людина, яка дуже багато років має справу з студентами, аспірантами і так далі, повинна відзначити, що ця робота відповідає найкращим дипломним магістерським проєктам. І вона одержала високу оцінку, і дуже хочеться відзначити керівників цього проєкту, і Юрійовича Циганенко-Дзюбенка та Галину Віталіївну Схибу з Житомирської політехніки обидва. Це чудова робота, і наша просто вам повага і хвала. І нарешті перше місце. Це Ілля Желєзняк. Оце саме цей хлопець одержав від всіх членів журі по 5 балів. Це єдиний випадок на моїй пам'яті у роботі нашого конкурсу. Тобто ми поздравляємо Іллю. Дуже хороша робота, оригінальна, розумна, чудово виконана і абсолютно відповідає тим навикам, які надає своїм учням Віктор Петрович Колдун. Ми багато років його знаємо, він багато років присилає своїх учнів на наш конкурс, і завжди роботи його учнів дуже цікаві і викликають велику зацікавленість і у членів журі, і у слухачів. Проте такої історії цього року відбулася, коли всі члени журі дали по 5 балів, такого ще не було. Тому я тебе, Ілля, поздоровляю, ти великий молодець, і ти поїдеш зі своєї роботи, саме ти поїдеш до Швеції і будеш її представляти на Стокгольмському водному призі. Оце все, що я хотіла сказати усім учасникам, і в першу чергу вам, Ми хочемо побажати найкращих успіхів, найбільших успіхів в подальшому і в житті, і в науці, і в участі в нашому конкурсі повторно. І нарешті особливий приз, відзнака за ефективні рішення у сфері водокористування громади, який ми з великою радістю, з великою приємністю передаємо, відзначаємо хлопцям з Лісоводського професійного аграрного ліцею. Це дуже хороша робота, дуже актуальна. Вона була б прийнята на будь-якому рівні, якби хлопці знали англійську мову. На жаль, цього не вистачило. Тому ми зупинились на тому, що ми спеціальну відзнаку утворили за ефективні рішення у сфері водокористування. І окрім грошової премії, цей ліцей одержить від нашого спонсора Екософту портативну лабораторію, щоб хлопці могли оцінювати склад очищеної дощової води після всього, що вони з нею роблять. Теж бажаю подальших успіхів, ви дуже великі молодці. Звичайно, вибачте.
Це лісоводи. Нам надзвичайно цінна ваша думка. Дуже приємно.
Робота прекрасна, да.
Реально проблема з англійською мовою частково, тому що хлопці з звичайного села, і в нас не такий високий рівень.
Але я розумію, ми все прекрасно розуміємо.
Високо оцінили, це така велика подяка і низький уклін вам. Ми будемо дуже старатися, тим більше нас основний учасник Тарас, який добре знав англійську, захворів, так все вийшло. Але все одно ми дуже вам дякуємо. Дай Бог вам здоров'я. І всім учасникам успіхів і велике дякую.
Також, Наталія Анатоліївна, ви теж нас настільки порадували з хлопцями. Це чудова робота, і ми дуже раді, що вона, насправді, з практичної точки зору, вона найкраща. Тому що це дійсно дуже актуальна проблема. Особливо зараз, в Україні, коли води нема. І ти не знаєш, що чекати, що буде завтра. Тобто, це супер рішення. Тому працюйте далі і успіхів вам, здоров'я і витримки.
Дякую.
Отже, дякуємо, колеги, дякуємо, Тетяна Євгенівна, за оголошення результатів. Дякую всім керівникам, всім конкурсантам, суперфіналістам. Будь ласка, не зупиняйтеся на цьому рівні, який ви сьогодні досягли, бо суперфінал водного призу на національному рівні – це вже є певне досягнення. Будемо раді вас бачити в наступних наших конкурсах. Там дозволяє вік, 10 класи спокійно можуть продовжувати роботу над своїми проєктами і подавати наново свої дороблені, оновлені з тими коментарями і побажаннями від журі роботи. Ми будемо раді вас всіх бачити. Організаційні питання. Завтра ви на пошту отримаєте лист, де буде розписано, яким чином вам будуть передані премії, відповідно, дипломи і подяки всім керівникам будуть надіслані до 15 травня. Це я також окремо все пропишу. Тому, якщо у вас будуть якісь організаційні питання, можна писати мені на пошту. Ще раз всіх вас вітаю, дуже вам дякую, дуже приємно було з вами познайомитись. Будь ласка, бережіть себе, працюйте далі, займайтеся наукою. Всім до побачення.